Hello guys, welcome back to Maison African Motives, still on mathematics and two revisions, working on trigonometry. We are given the question from April 2016, that is on question number 5. In this case, to consider fig 2 below, where we are given triangle ABC and triangle ACD are two right-angled triangles. Okay, so we are given these two triangles here. The triangle ACB, the triangle ACD, right-angled at point C. Remembering that angles on a straight line, they add up to 180. So if this is 90 degrees, it also means that this is also 90 degrees on this end. All right, so that means from the other end here, we are going to have a 90 degrees. All right, so that is the idea of the question. This is 90 degrees. This is 90 degrees. So if we are to add this, we are supposed to obtain 180. Okay, so we are given the dimensions and also we are given to determine the following. 5.11, the magnitude of the angle theta. So that is the first part of the question, to determine the angle theta in this case. Okay, so this is where we are. Okay, this is our diagram like this. Let me try to reduce a little bit like this. Okay, so how can we determine theta from this information that we are given in this case? All right, so if we are to check here, we are given, according to this angle theta that we have in this triangle ABC, which is a right angle triangle, we have got the sides B, C, and the side of AB. This side of AB, which is opposite to the 90 degrees, which gives us the hypotenuse in this case, and the BC being adjacent side. So this is our adjacent side. Theta and 90 degrees, they are adjacent to each other. So you've got adjacent and hypotenuse at the same time. So remember what I said, if you are dealing with a right angle triangle, think of the trigonometrical ratios that is from our SOHCAHTOA. All right, so from these mnemonics, there is only one ratio that uses, or that he has got adjacent and the hypotenuse at the same time. Which ratio is that one? That is the ratio that you're going to use. Adjacent hypotenuse is only found on cos adjacent hypotenuse. So it means the cosine of theta, which is our angle, is equivalent to the adjacent over the hypotenuse. This can help us to determine the value of theta because we have these values. So we can substitute the value of A, which is our adjacent that is our A, B from A to B. So adjacent, sorry, that is the BC, the one that we are supposed to this one, the BC, this one, the one that is to the horizontal. Okay, so that is 128 over the hypotenuse, which is the longer side of 134.5. That is the idea in this case. So how can we determine our theta if we are given this fraction? To determine theta, that is shift cos from your calculator, or simply add cos of 128 over 135.4, 134.5. So this is 134.5 degrees. The answer is going to be in degrees, all right? So what I'm simply saying is we need to determine the value of theta now from this cos. So it's from your calculator, that is shift cos, you insert the fraction, you determine the exact value of theta, which is going to give us 17,885 and so on, 536. So this is going to be 885 to 3 decimal places. So this is our theta in degrees. All right, so we are given our theta is 17,885 degrees in this case, which is the angle that we calculated from the ratio of cos. We applied the ratio of cos to determine this side. Okay, so you can play around with any information, but I think for this one, that is the only part that we can use. The length of side AC. Okay, so now we are supposed to calculate the length of the side AC, that is from A to C. So according to our triangle, this is where we have the point A, the point C. From the information that we had before, if you are to consider triangle A, BC, this triangle. We can apply Pythagoras theorem to calculate the third side because we are given two sides. So we can calculate the third side from Pythagoras theorem, or from the theta that we calculated, this one, we can calculate also AC using the trigonometrical ratios, because according to this theta, this is going to be your opposite. So you're going to use any ratio as long that ratio is got opposite, because you are referring to the theta. So as long that ratio is got opposite, that means we can calculate AC. What am I trying to say? I'm trying to say in this case, from this one, we have got opposite on sign, so we can use the sign of theta to calculate this side. I'm just going to write down what I'm trying to say in this case. So this is 5.12. So we can use the ratio of sine of theta, which is our theta is the angle of 17,885 degrees, which is equal to the opposite over the hypotenuse. The opposite is the AC that you're asked to calculate over the hypotenuse, which is 134. So that's 134,5. So you can calculate AC by cross multiplying this part. We can have our AC, or we can apply the tan of theta, which is opposite over adjacent. So you can use tan this angle is equal to opposite, which is AC over adjacent, or we can apply the Pythagoras theorem so many ways. Okay, so that's what I'm trying to say in this case. Okay, so from our Pythagoras theorem, like I was saying, that we can simply apply the Pythagoras theorem, since already we are given these values. These are the original values from our diagram. That was our A, and this is our B, C. From this part, I'm just going to take this part here, from A to B to C, this part. We are given A, B, and we are also given BC. So which means we can apply our Pythagoras theorem. Remember that our Pythagoras theorem states that H squared is equal to A squared plus B squared, which is the other side squared. So the hypotenuse squared, which is the side of AB, and we are given that AB is 134. Take note from our diagram, AB, that's 134,5. And the other side that you are given, it's BC of 128. So this is going to be 128 squared. So we are going to have 128 squared, which is added to the side that you're supposed to calculate, which is the AC. So this is going to be AC squared. So we can calculate AC from this information from our Pythagoras theorem. We can transpose and find AC. Transpose 128 squared to the left-hand side. This is going to be 134,5 squared minus 128 squared is equal to AC squared. So to determine AC, we can introduce the square root to get rid of the square and the square root. That is going to give us AC. So from our calculators, we are going to obtain something like 41,306.77 and so forth. So to 3 decimal place, this is going to be 41,307. The 7 is going to change 6, which is in centimeters. So that is our AC. So like I was saying, we could have calculated this value from the angle that we calculated, or the angle that we had before. That is going to give us the same thing. So so many ways we could have calculated it from this one, where we said the sine of this is equal to, or we can use tan, whereby you can even cross multiply and calculate AC. This is same as over 1. So that means 1 times AC is AC, which is equal to this one times this one. That is 134,5 times the sine of 17,885 degrees. So you can even use this to calculate the value of AC. All right, so you just have to apply your calculations properly. Okay, so that was our question for 5.12 to calculate the side AC. Now we have got this side AC, so you can even substitute on the, just put on the diagram. Then now the magnitude of the angle beta. So we need the angle beta. That is, give your answer for beta in radians. So beta is supposed to be in radians, and this is where we have our beta here. Take note, we calculated AC. We have this side here. We calculated this AC. We got 41.307. 41.307 centimeters, depending with the calculations that you did. Sometimes it can give us another value which is not exactly the same as this one, but they will be in the same range or same interval or just same range. Yeah, same range. So in this case, how can we calculate beta? If you are to consider this triangle alone, A to C to D, this is where we have our beta in this case. So in order for us to have this angle, you can name our sides or the sides that we are given according to beta. This is the opposite and this is the hypotenuse. So meaning to say, we need the ratio that uses the opposite and the hypotenuse at the same time. And we saw that from our SOHCAHTOA, that is this one is taken from sine. So that's 5.13. So remember, from your SOHCAHTOA, we can see that this is opposite of adjacent from the sine of theta, but this time this is sine of beta. So the sine of beta is equivalent to the opposite over the hypotenuse, of which we have the opposite according to the AC that we calculated, that is your opposite, which is 41.307 over the hypotenuse, which is 56.9. So just like what we did on theta, it was cos theta is equal to, find theta, it was arc cos of theta or shift cos from your calculator, or which is referred to as arc cos. So which means in this case, we are dealing with sine. So that means the beta is going to be the arc sine of this whole part, which is 41.307, everything over 56.9. So this is going to give us the exact value or the exact angle for beta. So on your calculator, make sure that your calculator is in radians, since we are given that this beta is supposed to be given in what? In radians. So you convert your calculator to radians. Okay, so let me show you. Let me try to put the screen on a calculator. So beta in radians. Okay, so let me show you on the screen. Let me just put the whole screen. All right, I hope you can see. Okay, so from this part, since beta is needed in radians, this is what you're going to do on your calculator. All right, so let me say the calculator. You change this D on your calculator. This is for degrees. So you change this one to radians. So it's shift set up. You go to rad on 4, which is like this. So it must indicate R. Now there must be R on your calculator. Okay. So with this R, for you to simplify this, all right, I need to remove this one. We now have this R. We need to simplify now the value that is shift sign, that is arc sine. So this is shift sign like this. You insert the values. Your answer is going to be given in radians direct. So this is 307 over 56.9 like this. All right, so that is what you're going to have. So this is your arc cos, your arc sine in radians, which is 0.81246 and so forth. So 0 to 3 decimal place, that's 0.812. All right, so this is going to give us 0.812 in radians. All right, so that's how we can convert from that is how we can use our calculator to give our answer in radians. If the answer was needed in degrees, which means on your setup, you must have in degrees at 3. It must have this D on your calculator. If you are to simplify, it gives your answer in degrees, 46.54 and so on. The answer is in degrees. So you can have your answer in degrees, then you convert. After that, it's up to you, depending with your simplification. So you can have it in degrees, then you convert to radians. Since we know that pi radians is equivalent to 180 degrees, you can do that, or you can just use your calculator at once. All right, so that was the simplification on how to use your calculator to simplify this in radians. All right, we move on to question 5.2, where we are given in this case to calculate the value of A. That is for the following trig equation. So we are given the following trigonometrical equation for us to determine the value of A. That is 3,5 tan A plus 7 is equivalent to, and we are given that our A is taken in the interval of 0 degrees to 360 degrees. That is where we are going to have our values of A. So what does it mean? From this interval, that is where we are going to have A, because A, there are so many values, there are so many answers that you can have, but within this interval, you will be limited on the answers that you're going to take. So what is important is that you express this as a single trig, that is either tan of theta it must be equal to a certain value. Sine of theta is equal to a certain value. The cos, you must have it as a single trig, so that we can find what we call the reference angle. I talked about that one before. All right, so this is what we are going to do. We are going to make tan A the subject, which means we are going to transpose to make tan A the subject. So that means we can transpose. First, 7 is adding, so you can just transpose this to subtract. On the other side, remember, if the number crosses the equal sign, it changes its sign, so that is going to be a -7. So we are left with 3,5 tan A. 3,5 is multiplying. So if you're multiplying, you divide to remove that number. So you divide by 3,5 both sides. That means we are going to have the tan of A, which is equal to -7 divided by 3,5. This is 3,5, not 35, but 3,5. We are going to obtain -2. So at that stage where you are now having the tan of A as a single trig, function, or a single trig ratio, that's where we can determine the reference angle, whereby the reference angle is simply the acute angle that we determine from the arctan of the number that you are given. So it's going to be arctan of 2. The negative that you are seeing here is for the quadrant. It indicates the quadrant. So this one, it indicates the quadrant where tan is a negative. Where tan is a negative. All right, so that is the whole idea of the negative. So when you are determining the reference angle, you do not involve this negative. You neglect this negative. You do not include the negative in your calculation. You put it aside. You are going to refer it back when you are now calculating the actual angle A by the quadrant now. That is where this negative is going to play a role to say which quadrant do we have our tan being a negative. So on the reference angle, don't consider the sign, okay? You put it as a positive. So that means the reference angle is going to give us, using our calculator this time, make sure that you change your calculator to degrees, because last time we changed our calculator in radians. So make sure that you change your calculator to degrees already. Mine is it. So make sure that you put the 3 back so that it is going to show you this D. So then you can determine shift tan, that is arctan 2 in this case. All right, so this is going to give us 63,4349, and so which is going to be 435. So it's 63,435. So this is going to be 63,435 degrees, like this. This angle that we are seeing here is not the actual angle. Be very, very careful. This angle is the reference angle, which is the one that is going to give us the exact solution. Remember what I said from the other questions that we did? I told you guys that the reference angle is going to affect each quadrant, okay, from the cast concept that you're going to apply. All right, this is your cast. But what is important is that from the reference angle in the first quadrant, theta, which is the actual angle that you are calculating, is equal to the reference angle. In this case, theta is representing our A. Just remember, it's tan theta, sine theta, cos theta. So this theta is A according to this question. So your A is equal to the reference angle. In the second quadrant, remember that your theta is equal to 180 minus the reference angle in this case. which is our theta being A. So it means our A is going to be 180 minus, okay? In the third quadrant, you add the reference angle to 180 degrees. So that is how you can calculate our A. In the fourth quadrant, we subtract the reference angle from 360. So it's 360 minus the reference angle. So that is how you now have the final answer from the quadrants. Like I said, the negative indicates the quadrant where tan is a negative. So now, where are we having our tan being a negative? As you can see, tan is positive in this quadrant, in the third, and in the first quadrant. That is where tan is positive, where we have T, and this one for all, which means in this quadrant, tan is a negative. In this quadrant for cos, tan is also a negative. So tan is negative in the second quadrant and in the fourth quadrant. Remember, this is our first, our second, our third, our fourth quadrant. So in the fourth quadrant, that is where our tan is a negative. So therefore, our A representing the actual angle theta. In the second quadrant, we said it is going to be 180 degrees minus the reference angle. The reference angle is the one that we calculated here, which is 63,435. So you're going to subtract that one from 180. You obtain the exact value or the actual angle, which is our A according to this question, which is going to give us 116,565 degrees, okay? Or we move on to another A. Remember, we said tan is also negative in the fourth quadrant. And in the fourth quadrant, theta, which is the actual angle, which is our A, is equal to 360 degrees minus the reference angle. So we are going to subtract the reference angle from 360. So that's 63,435 degrees, which is going to give us the value of A. So A is like theta. Just like theta, they can use a letter, they can use M, they can use N, they can use P, they can use any letter, okay? So that is the angle theta. So this one is going to give us the exact angle for A, which is 296,565 degrees. So that is how you determine angles, solving of trigonometrical equations. That is how you can apply your quadrants to assist you to calculate the exact angle from the reference angle that you calculated before. All right, so that was the question 5.2. We move on to question 5.3, which is last part of this question, applying the angle of elevation in this case. So in this part, we are given that an observer is standing 25 meters from the foot of a tree. Okay, so we have got an observer from the foot of a tree. So we've got a tree in this case that we are having. So we are given an observer from a certain point. Okay, so this is our tree. Then the observer is at this point. So the observer is standing 25 meters from the foot. This is the foot of the tree. So from to this point, that is where we have the 25 meters. The angle of elevation to the top of the tree, that is when this observer is looking on the top, at the top of the tree at this point, in this case, he is using an angle of 57 degrees. That is the angle of elevation going up. So that is our diagram in this case. So the question is to calculate the height of the tree, which is actually the perpendicular height because it meets with the horizontal line at 90 degrees. So you need to calculate H, that is the perpendicular height of the tree. So which concept? You are now back because by just drawing this triangle, by just having your triangle, you ask yourself, what type of a triangle am I having? That's a right angled triangle, which means that you are supposed to think of the trigonometrical ratios, why there is an involvement of an angle inside. We're supposed to think of those ratios, the ratios of cos, sine, and tan. But how do you know now which ratio to use? You know it according to the sides that is given according to the angle of 57 degrees. This H that we are supposed to calculate is the opposite. It's opposite to 57 degrees. So you take it according to the angle. So this is opposite. Then the 25 degrees is our adjacent. Okay, so there is only one ratio. So which one? are we going to use? That has got opposite and adjacent at the same time. So we have got soccer, tower in this case. So there is only one ratio that has got opposite and adjacent, only on tan. So that means the tan of theta is opposite over adjacent. We can use this ratio to determine even a side. It's not about calculating angles, even calculating sides. That means the tan of theta in this case, which is 57 degrees, is equal to the opposite according to 50. Our opposite is h. So that's h over the adjacent, which is our adjacent is this side of 25 meters. So we can calculate h, taking note that this is same as over 1 as a fraction. So we can cross multiply so that we can determine h. So it's 1 times h, which is h is equal to 25 times tan 57. That is 25 tan 57 degrees. So making sure that your calculator is in degrees. So don't evaluate with the values in radians while there is degree here. Make sure that your calculator, there is that D that is showing on your calculator. Okay, so this is going to give us something like 38,4966,241 and so on. So to 3 decimal places, our h is going to be 38,497. Okay, that is in meters. The other dimension was in meters, so this is going to be in meters. So the h is representing what? The height of the tree. So the height of the tree, which is our h, is 38.497 meters. So that is how we can apply or use our trigonometrical ratios to calculate size given an angle and one side. As long you're given one angle and a side, you can use the ratios, and provided it's a right angled triangle. That is the major thing that you're supposed to take rid of. Okay, so that's it for now, guys, from Mason African Motives, working on trigonometry for mathematics N2, till we meet again.